All right, so ready today. Any questions before we get started?
Can we decide what day our exam's going to be on?
Sure. Let me go. Well, let me go see what day it's scheduled for, and then we'll look from there and see what we want to do. Just a second here. Final schedule. All right, so for our class, which is at 1 o'clock, and so we can do Wednesday at 8 a.m., or we can do Monday at 3 p.m., or we can do any time before basically Thursday at 5 p.m. Suggestions, comments?
I don't know if like sooner is better than later in terms of like retention of information,
Okay.
but
Well, do you want to do Monday the 12th at 3 p.m. then?
That's fine with me.
All right. Let's have it that day then. So Monday the 12th at 3 o'clock, and that's 1400.
Monday's the 11th.
Well, I'm just going by what they say. So if it's the 11th, then we'll go with it. Well, then I wonder if they want us to say on Tuesday the 12th and they put Monday the 11th. Yeah, that's what it's supposed to be. They just have a typo in their schedule. We can do Monday the 11th if that fits everybody's schedule.
yeah, that works for me.
Okay. Yeah, I'm just going by what this calendar here says for that on the college website. So yeah, we'll do Monday the 11th at 3 o'clock.
Great.
I'll send out an invitation after our meeting today.
Someone should probably tell them they have that a typo on there.
You know what? They can figure it out. We figured it out. We're pretty smart, so I just didn't have a calendar to know what day we were on. So, all right. So let's start. Today we're going to do Chapter 4, Exponential Logarithmic Functions, and we're doing 4.5, which is logarithmic properties. So these are a lot of the properties that are help us solve things a lot easier. So let's move on.
Are we doing a review on Thursday still?
Yeah, that's the goal anyway.
Okay.
All right. So we have a lot of different rules, and the rules, again, like I said, they make it so we can simplify problems to make it easier to solve. Sometimes we can even change bases if we need to. So if we actually have to have an answer, we can do a log base 3 of 100 and solve that equation. So what we're going to do first, though, is a product rule. And basically, it's to simplify a logarithm of a product by rewriting as a sum of individual logarithms. So we're going to have some log base b, it doesn't matter what the b is, of m times n. And so sometimes this m times n is not a factored form. And so it might be, maybe initially it was something like 8k. And then we have to factor it into all the products. And then after we do that, then we can say, okay, well, that's equal to log base b of m plus log base b of n. So we can split up a product into the sum of two logs in this case. And again, b has to be greater than 0 here. All right, so like I said, we have to factor in prime factors. So what we're going to do is we're going to look at the first one here as an example to kind of see what we're doing. And so this is going to be equal to log base b. Now 8, we want prime factors, so that's going to be 2 times 2 times 2, 2, 4, 8, and then times k. And so what's going to happen is we're going to have logs of 1, 2, 3, 4 things added together. So we're going to have log base b of 2 plus log base b of 2 plus log base b of 2, and then plus log base b of k. Now, if we notice, that is the same as that is the same as that. So we could add those together, and that's going to be 3 log base b of 2 plus log base b of k.
Why do you have to expand it like that with the
Uh,
2 times 2
it, it,
times?
It's just going to make certain problems you're going to find we're going to have later. It's just going to make it going to be easier to solve an equation, because if we have it in this form, it might not be as easy to simplify as here, because this one we can actually get a number for. If we knew what the base was, we could actually calculate that one. And then this part we could use our exponential thing and say b to on whatever's the other side of the equals raised to that power is equal to k. And what's going to happen is we're going to take this to the other side, and then all it's left is that k that we have to solve for. So that's why we're doing this, to make it simpler to solve equations in the near future here. And so this is a prime example of that, when we have things we can solve for equations. So maybe this was set equal to some number. And so what we could do is we could break this down into, now this is log base 10, so that's just log. Now, what are the factors here? Well, we can pull out a 2, and we can also pull out an x. So 2 times x, and I'm just going to write it as two different factors. And after we pull that out, what's left? Well, if we pull out a 2x here, that's going to be x, and we pull out a 2x here, plus 3. So we've got, basically, if we want to put everything in parentheses instead, we have those three terms that we factored it into. That's the prime factors. And now we can just break it apart and say, well, that's log of 2 plus log of x, and then plus log of x plus 3. And again, this is going to help us when we get equations, we have to solve them. Breaking it apart sometimes is the easiest thing to do, and to be able to actually solve the actual equation. So that's what we're doing here. We're just kind of practicing going from one way to the other. Now, the other thing we can do is we can go back from here back into this, because maybe for some reason we need it to have it all combined, and so we can go both directions, and we'll see that here in a little bit. We have to condense things instead of expand. So right now we're expanding. Okay, and so that's how we expand. We just break it into the prime factors and then add each of them together with a log in front of it. We also have the quotient rule. So this is the product rule. So the quotient rule says, basically, if we have some m divided by n, what we do is we take the log of the numerator minus the log of the denominator. Okay, and so we can split apart things like that. Now the key thing is if there's still a product here that we can multiply or factor out together, what we'll want to do is we'll want to factor first, and then if there's any possibility of cancellation, we'll cancel. And then after that, we'll split it apart. And so this one, we're probably going to have some pluses on the numerator. So we'll have plus, plus, plus. And then with the denominator, then we'll subtract off each of those terms. So let's go ahead and first factor that. So not log. And so the numerator, we can pull out, we'll have a 7. We'll have an x. And after we pull out a 7x, we have an x plus 3. Then in the denominator, we've already broken it down. They said, well, there's a 7, there's an x minus 1, and an x minus 2. And so that's where we're at this point. Now, like I said, what we'll want to do is we'll want to cancel anything that can cancel. So our 7 cancels that 7, that x cancels that x. None of those can cancel, so we're done with the cancellation. And now we can write it. Now, remember, it's going to be the log of the numerator. So that's going to be log of x plus 3 minus each of those is going to be a log of that. So then we're going to have the way to do this. We could do two different things. We can take, we could do this and say log of x minus 1 plus log of x minus 2. And then we have to distribute to get rid of those parentheses, and we get log of x plus 3 minus the log of x minus 1, and then minus the log of x minus 2. Or we can automatically know that, when we did the products, it's just going to be the log of each one of those added together. But because they're both in the denominator, we know they're both going to end up having a minus like this. Okay, so the numerator is going to be positive. The denominators are always going to be negative. So if we have two factors, it's going to be minus one of them minus the other one. So this would be, the first step if we did it in 2 steps. Otherwise, we could go straight to there and have that step there. So kind of depends on if you need to look at it in the 2-step mode or just the 1-step mode like we have here. Now we can also have a rule called the power rule, and that means we're going to have something, some m raised to some n power. And if you remember before, we kind of had this already because we know when we took the ln of e to the x, we could bring down the x, and that was x ln of e, and that was just once, we just had x. But now this time we don't have exactly always the e or even the base 10, but we can still bring down that n out front, and it's going to be n times what's left over, the log base b of m. Okay, so those exponents we just bring down to the front, and so this is just equal to x, or not x, but 2. So that's 2, and then we have ln of x left over, and then that would be our answer. So all we're doing is bringing down that 2 out front. Now, when we have something like this, we can't always just, do that. What we have to think about is putting everything in the numerator. So if we do that, what is that going to be? Well, if we take that to the numerator, that becomes x to the negative 2. Now, that's more in the form of this, where we have some m to the n power. So now we can bring that 2 down in front. We have a negative 2 times the ln of x. So sometimes you have to think about, what does this mean? And well, we have to get it to the numerator. And when we do that, we get the negative 2. And then that negative 2 comes out in front times just the ln of x in this case. Okay. So those 3 rules are going to help us simplify more complex things. So this one was probably the most complex at that point, but a lot of that canceled, and then we just had the quotient here that we had to worry about, and then the product in the denominator we could split apart into what we have here. Now, sometimes we have things that are a little more complex. In this case, where we have things in a numerator, things in a denominator, things don't cancel. And so what we can do is we can look at this in 2 ways. I'm going to do it first as taking that z to the 4th in the numerator. And that way I can think about it as that power is going to be able to bring down once we get it split into pieces. So this is going to be, for me, log of x squared times y to the 3rd times z to the minus 4. And it works out either way, whether you do it this way or the other way, and I'll show you both ways. And so now this is a log of products, so then we just take and add them together. So that's a log of x squared plus the log of y cubed plus the log of z to the negative 4. Now we can use the power rule and bring each one of those down in front. And so that gives us 2 log of x plus 3 log of y, and now that's a minus 4, so that's going to be minus 4 times it's log of z. Okay, so that's what it looks like if you expand it and put everything in the numerator and bring it down, because our negative 4, if we think about that, we should have just subtracted that there, but what we did is we put it in the numerator and we got that. Now if we'd gone the other way and just did it with log of that plus log of that minus log of that, what we would get is log of x squared plus log of y cubed, and then we'd have minus the log of z to the 4th. Now we're at the point we can bring down everything like this, and we get 2 log of x plus 3 log of y, and then we have minus 4 log of z. So those 2 match. So it depends on how your brain thought about it and how you wanted to do it. If you wanted to put everything in a numerator and then simplify after that, or if you just wanted to do the quotient rule and work it out that way, and then use the power rule and bring everything down. Both of the ways are correct. Both of them give you the same answer. All right, so what about the next one? Well, the next one, what I think is going to be the easiest is to get rid of our roots. And how do we get rid of our roots? Well, if we think about it, if we have the cubed root of x, let's just worry about that. What is that equal to? Well, that's equal to x to the 1/3. Okay, so what do we have here? We have the ln, and if we're looking at just what's under here, that's x squared. Now we're going to go ahead and put another set of parentheses here. And then that cubed root gives us the 1/3 power. And so this is what it really breaks down to. We're taking the cubed root of x squared. Now what I'm going to do is I'm going to multiply those two together. And when I do that, we have ln, and power rule just says that's going to give us x to the 2/3. Okay. Now, if we want to get rid of powers, what we're going to do is we're going to bring that down in front. So that's 2/3 ln of x. And so that would be then our final answer. Okay, and so this one we had to know that the roots basically, we're going to get to the 1/3. If this had been the 8th root, that would be to 1/8. And then when you multiplied them, you could reduce to get 1/4, and then you would have brought that down as 1/4 ln of x. But in this case, we had the 3 and the 2 here, and so that's how this one worked out. So again, remember, when you have whatever your root number is here, that's just x to that 1 over that power, okay? And so that's how those work. And so that's how we're going to work those in these kind of problems. All right, and so here's another one where we can do the same thing. We have, in this one, we have to the 1/2 power because we have the square root. So we can simplify this into, now on the denominator, what we have is x squared minus 9. Well, that's a difference of squares. So that's just going to be x plus 3, x minus 3. So that part was pretty easy. Now the numerator, we're going to take each of those to the 1/2 power. So we're going to have x minus 1 to the 1/2. And then we're going to have the 2x plus 1 squared to the 1/2. And then in parentheses. Now when we look at this, 2 times 1/2, well that's just going to cancel, and we're just going to get this to the 1 power. And so if we rewrite this, that's ln of x minus 1 to the 1/2, and then it's times 2x plus 1, and then we still have all over x plus 3, x minus 3, okay? Now what we can do is we can use our quotient rule as well as the product rule and break that down into, now it's going to be the ln of that first part, ln x plus or minus rather, minus 1 to the 1/2, and then plus, because that's still the numerator, ln of 2x plus 1. Now we can subtract off ln of the first one, x minus 3, and then minus the ln of x plus 3. So I wrote them in backwards order, but that's okay. Now we look and see, do we have anything with powers? Well, this one has a power, and so what we're going to do is we're going to bring it down in front. And so that gives us 1/2 ln of x minus 1, then plus ln of 2x plus 1, minus the ln of x minus 3, then minus ln of x plus 3. And so that would be our expanded form of our original expression that they gave us with the ln of the square root of blah, 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 blah. So that's just how we're going to expand it out, and that would be then our final form. And again, this is just to kind of use all the different rules we've got. We've got the product rule, the power rule, and the quotient rule all in one problem, and we simplified it down into this once we've expanded it. Okay. All right, so we've been expanding, so now what we're going to do is we're going to start condensing. And basically, we have to have logarithms of the same base. So that's the key thing. You have to have logarithms of the same base, because if you think about it, we had the same base. Everything was ln, or everything here was log. And so everything has to be the same base. And what we're going to do is we're going to apply the power property first. So look at the terms that are products of factors and rewrite as a log. So, if we had the 1/2 to the ln of x, well, we're going to take that back up, and that's going to give us ln of x to the 1/2. Or we could say, that's ln of the square root of x, depending on how we wanted to write it. Okay, so that's the first thing we'll do. Next thing, we're going to apply the product property. So if we had a sum of logs, they had log maybe of x, and then plus the log of 3, we're going to say, well, that's the log of 3x. Okay, and so we just apply the product property in reverse order, so that's going to be 3 times x. And then we apply the quotient property. So maybe we had the ln of x, and then we had minus the ln of x plus 1. So we're going to have the first one is positive, so that's going to be ln of x, and then, oops, need a little better space here. So that's going to give us, say, maybe ln, and then x is going to go in the numerator, and x plus 1 in the denominator, and so that's how we're going to convert that into one original problem instead of split apart, expanded. We're condensing it into this. So now we're going to basically go now into problems and expand them, or condense them rather now, into a single log. And so instead of 4 of them, we want a single log. Now we have to think about that. So we know it's going to be all log base 10. So now we have to think, okay, that's a positive, so that'll be in the numerator. That's a negative, that's denominator. That's positive, it'll be back in the numerator, and that's a denominator. So what we have is 3 times 5 in the numerator and 4 times 6 in the denominator, because those are the negatives. 4 and 6 and the 5 and 3 are positive. We can reduce, and so this is one possible answer, or we could even, put it as log of 15 over 24. But we could also say, well, that'll go in here once, that'll go in here twice, and so we get log of 5 over 8, which is what we would get if we would reduce this. And so I think the key ones are, you could have this one as one choice, and then this one would be another possibility because you've reduced it some. So this one we could get back to here. This one we could not get back to here. That wouldn't get us back to there, but it would get us to something that was equivalent to that. So, this is going to be an equivalent one. This one's going to give us exactly the same thing. And so that one is probably the most accurate. This one is the most reduced form. Okay. All right, so the next one is going to be the same thing. We have to look at the positives and the negatives. So this is the positive, so that's going to be numerator. That's going to be numerator. That's going to be numerator. And that's going to be in the denominator. So they're all log, so we have their same base, so that's going to be log. Now in the numerator we have a 5, then we have times 0.5 x. Well, actually we should take that to the powers first. If I'm doing this correctly, I guess. I forgot there was powers here. So this is going to go up here, and this is going to go up here. So now let's rewrite it as the sort of condensed form. This is a log of, now x to the 1/2 does the same thing as the square root of x, so I'm just going to put it that way so I don't have to worry about it. Then minus the log of 7x minus 1, and then this is going to be plus the log of x minus 1 cubed. All right, so now we're in the form where we could actually put it into the single log form. So in the numerator we'll have 5 times, now we have the square root of x, times, now we have x minus 1 cubed, all over, and we have just 7x minus 1. And if we parentheses around that. So that would be one form you could do. Now they usually don't have you expand out the x minus 1 cubed and then times all that. They let you keep it in this format here, and so that would be our final form of this expanded form here, and this is our condensed form here on the right. Okay, and so that would be basically where you'd stop. Now, if you wanted to, you could put the x minus 1 up here, cubed, then times the square root of x, but it really doesn't matter. Any order works here as long as you have all the correct values, the square root and the cubed value. Okay. All right, so what about this one? Well, this one I'm going to work with inside of parentheses first, get that simplified, and then worry about that 4 out front last. So that 3 is going to go up, and then I don't have anything else. And so then I'm going to have 4. And so that's going to be log of x cubed, then plus log of x plus 5, then minus the log of 2x plus 3. So now each one of those is a log, so that's all the same base. So I'll have 4 times the log. Now my pluses are these two, so I'll have an x cubed times x plus 5. And again, if you want to put them both in parentheses, that's fine. All over, we have the 2x plus 3. Okay, so that's that step. Now we can use this as a reverse power rule and take 4 up here. And so when we do that, that gives us log of x to the third, x plus 5, and then 2x plus 3, and that's all to the fourth. So that is one solution you could have. The other one would be actually use the power and take each of those to the fourth power. And so when we do that, that would give us x to the 3 times 4 is 12, and then we'll have x plus 5 to the fourth, all over 2x plus 3 to the fourth. And so that would be another possibility. So both of those would be correct answers, depending on if you wanted it left like this to the fourth power, or if you wanted to go ahead and bring everything in and have everything taken to the fourth power and get it all simplified even more and get rid of that power outside here. So both of those are correct. It just depends on how far you want to go. I would count this, the first one, correct, and I would also count the last one correct. It just depends on, you know, what you feel like doing as far as how far you want to go there. All right, so we also have applications of logs. And so the first one, and probably the most famous one, is probably the pH equation, where pH is equal to the negative log of the hydronium ion concentration. And so what it asks for is, how does the pH change when the concentration of positive hydrogen ions is decreased by half? Okay, well, if we decrease the H plus by half, that means we're going to have 1/2 of H plus. So what we need to do is we need to take the negative log of that. And so we're going to go ahead, and I'm just going to put this in parentheses because we're going to not worry about the concentration. That's just going to include the concentration. So we have minus the log of that. Well, now this is a product. And so what we can do is we can say, okay, well, that's minus, and let's say that's the log of 1/2 plus the log of H plus. And so now I have that split up into two pieces. Now I'm going to go ahead and take that negative throughout. So that's a minus log of 1/2 minus the log of the H plus. And now what do we have? Well, this number we can actually calculate on our calculator. This number, does it look familiar? Well, that's just the pH. It's minus log of H plus. Well, this is minus log of H plus. So if we convert that to pH, we can say pH and just move it out front because it's going to be positive in that case. And then minus the log of 1/2. Okay. So now what we need to do is we need to take the minus the log 1/2, and I think I forgot to open my, let me just a second, I forgot to open my calculator. So now let's find the calculator. Where did it go? Is it gonna work? All right, so hopefully, can you see the calculator?
Yeah, we can see.
Okay, cool. So then what we need to do is we need to take minus, and we need to use this negative, so we're minus the log of 1/2, which is 0.5, and that's equal to 301029. So 0.301 is what we need. So going back here, that's going to give us pH plus 0.301. So what's it do to the pH? Well, it increases it by 0.301. So increases by 0.301. Okay, and remember we took that whole thing, we took minus the log of that, and so that's why it's plus. If you just had taken log of 1/2, that would have given you a negative 0.301, and then a negative of a negative is the positive. So you have to really watch your signs when you're doing this, because a lot of times you're going to get a negative if you just look at the log piece, but we're taking negative log of 1/2, and so that gives us the positive. So that's what it increases by here. Okay. All right, and so this is the one that actually is going to help you take logs of things that are not exactly ln or log. And what we're going to do is we're going to have some log base b of m, and we can have 2, 5, 10, 25 for our base, and not all of those we can do in our calculator. All we can do is log base e and log base 10. And so this will help us do others. And so what happens is we can make this become log base n, whether we want it to be 10 or e. Those are the two we're going to convert to, doesn't matter which one, of m divided by log base n of b. So basically we're taking and converting from whatever that base is and converting it to 10, which looks like the bottom one here, or to base e, which is the top one. Okay. And so that's going to be something that makes it so we can actually calculate any kind of log, and makes our life a lot easier, so we don't have to worry about some things. And so this is going to be a key thing. And you want to put it into log base 10 when you have something like, powers of 10 in here, like 100 or 1,000. And then the rest of the time, you're just going to use the ln, the natural log. So the common log is only when you have powers of 10. This is pretty much any other time. You can even use it for powers of 10 if you want to. It doesn't really matter. All right, so this one says change log base 0.5 of 8 to a quotient of natural logarithms and evaluate. Okay, so then we went around to 4 decimal places. Well, if we remember, what we do is we convert this into ln of 8 divided by ln of 0.5. Okay, so when we do that, let's go back over to our calculator. So we had ln of 8 divided by ln of 0.5, and that gives us a -3. So we don't really have to do any rounding, and that one is just -3. Okay, and so that would be our answer. But if we look at that, we could have never done that in our calculator because we don't have that function of 0.5. But we can do it when we convert it to the ln of m over the ln of n, or b rather. Okay. Now this one, like I said, when we have things of base 10, usually we use log. So we'll say that's the log of 100 divided by the log of 5. Okay, so log of 100 over log of 5. So log of 100 divided by log of 5. Okay, now let's just test it to say, well, what if I decided I wanted to use ln instead? Do we get the same thing? We do. So that's just to show you it doesn't really matter which one you do. The ln is usually the one I'll use most often. I'll just go to the ln because it's the easiest. But log is one that usually only works when you have log base, with 10 factors of 10. It's the best one to do there. But the ln is one you can use for anything, and it shows you get the same answer. And so that one then gives us 2.8614 rounded to the 4 decimal places. Okay, and so like we said, that was also the ln of 100 over the ln of 5. So it can go either way, and both of them give us the same answer. All right, so that finishes 4.5. It was easy. It's just those 4 or so functions or equations we had to do. And so what I'm going to do is I'm going to go on to 4.6 and just kind of work into that however far I can. So let me go in and do some stuff here.